Today's session is Achieving Great Output Quality with Your Paper. It is my pleasure to introduce our speakers for today, Lou Prestia, Senior Product Line Manager, and Heather Blakely, Product Marketing Specialist. So with that, let's begin. Lou, take it away.
Hello everyone, and thank you for joining. In today's session, we'll talk about achieving great output quality with your paper. In the session, we will learn some things about paper characteristics, including some details about paper manufacturing, some quality considerations when we're picking a stock, and some of the characteristics. We'll talk about optical brightening agents. We'll talk a little bit about good strategies for storing paper to get the best results on your digital printing system. We'll talk about configuration of the digital print system for your paper on your DFE, and we'll show some examples from the Fiery for that. Finally, we'll talk about some automated workflows for paper configuration and print processing. The last thing I want us to talk about today is I want to show you briefly at the end of our session, before we go to your questions, the way in which I can quickly and easily create a calibration and a profile, which is basically essential when I want to add a new paper to my Fiery if I want to get top quality color output. So when we talk about paper characteristics, the first thing to understand is that before we were manufacturing paper in the kinds of quantities we do today, paper was basically handmade using a process where we would create a slurry, which would be a mix of water and some kind of fibers, typically wood fibers, and we would put this slurry in a container, as you see here. We'd basically put a screen in there, spread the slurry on the screen. When we lifted the screen, what we'd have is a hand-laid sheet of paper, which of course we then had to dry and eventually peel off the screen, and we'd have a single piece of paper. Today, we have modernized paper mills where we manufacture paper using a similar technique, but rather than making one sheet at a time, we're basically laying this slurry on a conveyor screen, which moves through the machine and the paper dries as the screen moves. At the end, we are rolling up the paper as it's finished onto web rolls that are ready for distribution and shipment. So it's rather than one sheet at a time, it's a continuous feed manufacturing process that results in web rolls of paper. And that machine looks like this. One thing we can learn by understanding a little bit more about how paper is made and thinking about how this machine that you're looking at works is we can learn about the grain direction of the paper. So the motion of that conveyor as the paper dries and the fiber dries tends to align the pulp or the pieces of wood or whatever our material is in the substrate so that they're parallel. So that gives the paper a grain direction. And if I look at the paper under high magnification as we show here, you can actually see those grains of paper have all lined up in the direction of travel on that conveyor screen before they're rolled up onto the web roll. A couple of things to understand about the grain orientation. The first thing is, if you think about the grains of paper like little toothpicks or pieces of wood lined up next to each other and basically stuck together in the paper manufacturing process, then you can understand that if we have a change in humidity, the paper is going to tend to grow across the grain. That is, these wood fibers are going to tend to swell. They're not going to get much longer, but they're going to get thicker with more moisture. And that will cause the paper to actually grow in the cross-grain directions, to change size. We'll see what that leads to in terms of a problem in a few minutes. The other thing to understand about the paper grain is that I tend to have more dimensional stability across the paper grain. Notice how when you tear a sheet of paper, I'm sure many of you have experienced this, in one direction with the grain, the paper will tear very cleanly and straight because we're basically separating those fibers of pulp. If we try to tear across the grain, we have quite a bit more stability. We're trying to tear the toothpicks in half, if you will, and they tend to break in different directions and give us different kinds of quality. One thing we can see about grain is that when we bind a book, if we bind a book in the cross-grain direction, we can get cracking in the fold of the book or in the binding. So that looks like this. The proper way of manufacturing a book, if I'm going to do perfect binding and glue the sheets into the spine of the book, would be to manufacture the book the way we show on the top line here, so that the grains of paper are parallel to the binding of the book. If I bind it in the cross-grain direction, which sometimes for economical reasons is a more cost-effective or cheaper way to produce a book, but I bind it with the paper grain perpendicular to the binding, then what can happen when those sheets swell with humidity is the paper will grow vertically, in example number 2, and the pages will break out of the binding. Okay? Many of you, at least in the U.S., have probably seen a great example of this, which is our classic Joy of Cooking book, which you probably have a copy of this at home that looks just like this. The pages tend to break out of the binding of this book because this book is bound cross-grain. The grain is perpendicular to rather than parallel to the binding of the book. When we learn about paper characteristics, there's a few terms that we use that I want to get us all familiar with. The first is paper weight. The paper weight, as it's usually described, at least in the U.S., refers really to the caliper of the paper, refers to how thick or heavy the paper is. If we use the U.S. term of basis weight, then we typically talk about the weight of the paper in pounds. So you might see a 90-pound sheet or a 140-pound sheet or a 300-pound sheet. Naturally, these get progressively thicker as that weight increases. The paper weight, as we'll see in a moment, affects the digital print manufacturing. But before we go on, let's talk about another way of measuring paper weight that's commonly used in Europe and many other parts of the world. Rather than using the basis weight, which is calculated in the way we show here, we instead use what's called grammage. So the challenge with basis weight is that the weight of the paper has to do with weighing 500 sheets of the paper cut to a specific size, but the size varies. So if you want to talk about an 80-pound book, that's going to be a very different paper than an 80-pound cover, because the cover sheets are cut to a much smaller, basically half-sheet size compared to the book sheets, which are a full 25 by 38, the size of a 100-centimeter or 40-inch press. So the weight is sometimes misleading unless we're very familiar not only with expressing the basis weight, but also explaining whether it is a cover or a text or a book or a bond, which tells us about the size of the sheets that were weighed. If we compare this with grammage, which is to say the unit that is used in the rest of the world, grammage simply weighs one sheet of paper that is 1 square meter in dimension. So the grammage gives us a much more precise way to define the paper. Let's look at a couple of different examples. A common sheet that we might use in a manufacturing process to make a book or some kind of a brochure is we might use 80-pound text for the inside of the book, the page of the book. You can see that 80-pound text relates in the table here to 120 GSM stock. The difference is that if I say, let's use the 120 GSM media, I don't have to understand whether it's the book or the cover or the bond type of 80-pound that I'm talking about. Another example might be what we would use for the cover of the book, which might be what we call a 100-pound cover. Notice that if I was talking about book, this would be a 183-pound text paper. 100-pound cover is a typical cover material I might use for your brochure or booklet, and a more precise way to talk about that is we could say that that's 271 GSM paper. Okay? In general, on your digital front end, you'll see both these terms interchanged, but almost always we try to tell you the GSM, just because that grammage is a much more precise way to talk about the paper. The next thing to understand about paper characteristics is that some papers are coated. A coated paper has a layer of clay coating applied to the paper surface. We might compare that with what we call sometimes an uncoated sheet, or what in some markets we call a natural sheet, which doesn't have a clay coating on it. The clay coating allows for a wider color gamut and a better dynamic range when I print on the paper, especially in the digital process. The uncoated paper with no coating applied may be preferred for some print applications. Very typical that a designer might say, I really want to use the uncoated paper, but the nature of uncoated paper is that the toner is not going to adhere as well to the paper. So uncoated paper in general has a limited dynamic range and typically a smaller achievable color gamut than a coated sheet. Lastly, we sometimes talk about calendared or supercalendared sheets. This is another type of uncoated paper where we smooth the paper surface with steam and pressure in the manufacturing process. This is the type of sheet that's sometimes used for uncoated magazine pages if they haven't chosen to print a publication on a coated, thin coated stock. When we look at the influence of the coating on the printing process, the first thing we see is the difference in the colorant adhesion. With a clay-coated stock, I see this larger gamut because I'm able to image very sharply, and I'm able to get a very good transfer of my colorant, my toner, or my ink onto that substrate surface. If I compare this with an uncoated sheet, the same printing looks very different on an uncoated sheet, and this is magnified under a microscope, so it's not quite one-to-one with what you saw on the last slide. But what we see is that the toner or the colorant, the ink, is actually flecking off the paper. It's not sticking to the rough surface of the uncoated paper. Some people have the impression that uncoated paper sucks up color, that is, the ink or the toner somehow sinks into it, and that's why it looks more dull, and that's not really what's happening. The issue is that it's not sticking. The other thing to understand about coating, when we think about a laser imaging system, such as we have on our toner-based cut sheet devices, we're going to fuse the toner onto the sheet. So this is a basic image of how a digital press works. In a digital press, I transfer some toners, which is to say some powdered colorants that are made typically of some kind of plastic, onto the sheet, and then I run the sheet through a fuser. That fuser melts the toner and transfers the color to the substrate. What we see is that when we run heavier substrates through our digital presses, we typically need a higher fuser temperature. We need that to transfer or to melt that plastic colorant onto the substrate surface. And because I have that higher temperature, I get more colorant transfer. So if you look at this diagram, we show as the temperature changes, the toner smooths out, gets melted onto the paper. Thicker sheet, sometimes will run a little bit slower in some digital presses, but it typically will always have a higher fuser temperature, and that means that a thicker paper will typically get more color gamut and more transfer of the toner, especially on a coated sheet. The next characteristic to understand about paper is paper brightness or whiteness. Brightness is measured in a specific scientific way. It's the reflectance of a particular wavelength of blue light off the substrate. This is defined by the standards organization called TAPI in the US. And the blue light reflectance is at the 44 nanometer band, that's the wavelength of the light, or a 44 nanometer wide band at 457 nanometers. There's also an ISO spec for this called 2769. It gives a little more definition about how to measure brightness, but typically it's not used. Brightness ranges up to 100 in theory, but for a reason we'll understand in a few minutes, brightness values often go over 100. The other whiteness or brightness we need to understand is the whiteness defined by the CIE. This is the European standard, and this is the amount of reflectance rather than of a single blue wavelength at 457 nanometers. It's the reflectance of the entire daylight spectrum, the D65 spectrum. Okay? This has the same characteristics as brightness, though they're not one-to-one, so depending on where you're working, you might specify a paper as certain brightness level or certain whiteness level. But the important thing to understand is that a perfect score, if you will, is 100. The higher quality the sheet, typically the closer to 100 the brightness or whiteness would be, which would indicate a perfect reflectance, 100% reflectance of the blue wavelength or of the D65 light. Sometimes the number goes over 100, and we'll talk about why that is in just a moment. The main thing to understand about your brightness or whiteness is that if I have a sheet of a particular weight with a particular coating, and its brightness is 92, and I have another sheet that has all the other same characteristics, but its brightness is 98, typically I'm going to have a greater dynamic range on that print. I'm going to have a brighter white in the highlight, which will in turn make my shadow appear darker, will give me the illusion at least of a larger dynamic range on the paper. And we see the same things with brightness that we do with colorant adhesion. A smooth coated paper tends to reflect light very efficiently and have a higher whiteness or brightness value, compared with an uncoated paper, which has this rough surface, tends to scatter and diffract some of the light we're trying to reflect off it, and therefore these sheets will typically have a lower brightness or whiteness value reported. When we measure whiteness, when you look at the whiteness of a sheet, the other thing you'll see is much easier to understand and is actually internationally agreed upon. This is the paper shade. The paper shade just says what is the color of the paper. It's usually measured in LAB. Generally, a higher quality stock, a more expensive coated sheet, tends to be a little bit more on the blue side, tends to have a B star value that indicates it's a little blue. And as we move to cheaper sheets and uncoated sheets, things get yellower. So our B value tends to go up. Sometimes even B becomes greater than 0 on some of our mid-range sheets. Now we're ready to talk about the paper types you've probably heard about for a long time. Paper type 1, or a number 1 sheet, as it's sometimes called in the trade, is going to be the top quality sheet in your shop. It's going to be a gloss-coated paper, maybe a matte-coated paper, but it's going to be clay-coated, and it's going to have a high brightness value, and typically it's going to be on the blue side of the color shade. It might be B star of -2 or -3 or -4. These are the sheets, incidentally, that are used for most of our commercial press references for coated paper. By that I refer to Fogler 39L, to the GRACOL specification in the U.S. Those are typically for printing on the number 1 sheet. Number 2 sheet is another gloss or matte coated paper. Tends to be a little bit more yellow, tends to be a little bit less of a quality sheet. Number 2 sheet's not too typically used in production, or people interchange number 1 and number 2, and they're fairly similar, but again, one will be a little bluer and typically a little brighter. When we get to paper type 3, this is where there's a real difference. Paper type 3 is publication grade coated paper. This is a much thinner, much yellower sheet, historically used in a web press, used for printing publication work rather than commercial print work. If we have in our shop a number 1 sheet and a number 3 sheet, then chances are I'm going to have different setups for those two different kinds of paper. As we go up in the numbers here, number 4 is an uncoated white offset sheet. Number 5 is an uncoated sheet that is super calendared. That's the one that has the steam and pressure applied to smooth it. And this is typically what's going to be used in a publication, a magazine, or that similar kind of brochure if we want to use an uncoated sheet. Here's a specification of a GRACOL sheet, the number 1 sheet that's used for the GRACOL standard in the U.S. There's a number of characteristics here about what the solid ink densities will look like on this sheet, but from the perspective of just understanding the paper, the most interesting thing here is in the upper left. It shows me the paper shade, which is 95.0 -2. This paper probably has a brightness in the range of 95 to 100, or a whiteness, and this is going to be a coated number 1 sheet. Talk about some paper problems. The first problem we run into with paper, and I don't know about where you're sitting today, but certainly where I am, this is a big problem here. It's very humid. Humidity has a tremendous impact on the printing process. Number 1, it impacts your paper. Number 2, it impacts the way toners or colorants adhere to the paper, and also how the inks trap or stick together in the mid-tone to 3/4 tone. So it has a very big effect on color. When we talk about paper and humidity, typically this leads to the paper curling and not being so smooth, so I don't get such a good image transfer to it. Another problem I can typically have with paper is dust. This usually occurs with an uncoated sheet that's been manufactured very high speed, probably packaged into some wrapping. Sometimes in the process, what gets wrapped with the paper is some of the dust from trimming the paper, some of the little paper particles from the manufacturing. This will wreak all kinds of havoc in your digital imaging equipment because it will get in all the places that you don't want it. So a lesson here is basically to sample the paper you're going to print on. You might want to open up a pack away from your machines if it's a particularly affordable stock you're choosing to use, and make sure you don't have a lot of paper dust in there. And if you do, then of course you can fan those sheets out and jog them somewhere away from the equipment before you put them into the press. Another paper problem that our talk today wouldn't be complete without is to talk about customer requirements. Okay? This doesn't sound like a paper problem, but the problem that we refer to here is that the customer has a certain expectation for their print, especially a graphic designer and art director that's trying to achieve a particular look or some particular branding or other effect with their printed piece may well come to your shop and say, I want to print on this sheet, or look at a series of papers that you offer them and pick a specific one that their job absolutely has to run on. Maybe that's a matte finished sheet. You know, these dull matte sheets are very popular with the design community today. Perfectly fine to run that through the digital press or whatever press you have to do the printing on that, but you need to be aware that you're not going to have the gamut, the color range that you would on something like a #1 sheet. So if that customer says, this is the paper I want to use, we say that's terrific. If they say, now I want you to match ISO-coded Fogra 39L or GRACOL on that sheet, you're probably going to have a little conversation about the realities of the print manufacturing process. The other problem I want to spend a few minutes on is the issue with optical brightening agents. So an optical brightening agent, or what we're going to call an OBA for the sake of not having to say optical brightening agent too much, is a chemical that the paper manufacturer adds in the paper making process. The OBA is designed to make a low-quality sheet look nicer. Basically, it's a chemical that causes the paper to glow in the presence of ultraviolet light. White surface, like maybe you have a white shirt on in a disco, and you're in that black light and it glows, that's what the OBA is doing in your paper. One way I can identify an OBA is I can shine a black light on the paper, and you see how we see in this example here, the paper glowing. This is a sheet that has a large amount of optical brighteners in it. Okay? Nothing specifically wrong with optical brighteners. We want sheets to look bright and white and very high quality, even if maybe they're not the most costly material that we're choosing to print on. But the problem is that because these optical brighteners fluoresce or glow in the presence of ultraviolet light, we're going to have to take them into consideration when we make profiles for that paper. Here's the reason. The optical brightener makes the sheet look more blue. If I put a printed sheet in a light booth, which we should all be doing with our prints for our customer to approve them, that's the place where we would expect the color managed print to look its absolute best, I have the following problem. In 2009, the ISO changed the specification for light booths and added UV to the booth. So if you look back a number of years, you probably had some spectrophotometers that had a filter on them called a UV cut spectrophotometer. That UV cut spectrophotometer cut out all the effective ultraviolet light in your measurements, meaning no matter how much OBA was in the paper, you could measure it, filter out the effect with the instrument. Your light booth before 2009 also didn't have any ultraviolet light in it, so the sheet wouldn't glow in the booth. You didn't measure the glowing in making your profile, and everything worked very well. 2009, things got more complicated. Because the ISO added UV to the specification for the light booth, now if I measure a sheet that has optical brightening agents with a UV cut, a filtered spectrophotometer, I filter out all that glow, right? I don't get any of that bluing of the paper in my measurements. As soon as I show the customer in my modern light booth that print, they're going to say it looks too blue because it's going to glow to the blue. Okay? The way we solve this problem is we use a new measuring mode on the spectrophotometer. So there are 3 modes on most of your modern spectrophotometers called M0, M1, and M2. M0 is to include all the effects of ultraviolet light, meaning we measure all the effects of the OBA in the sheet. M2 is the old standard for cutting out all the ultraviolet light, and as I said, it worked terrifically up until 2009, but that's when this ISO spec changed and things got more complicated. If I really want to match a light booth and match color in a light booth, the condition that I should measure in is always what we call M1. M1 specifies that our measurements include exactly the same amount of UV radiation that's in the D50 light booth. That means that we'll get a very precise match when we profile that paper and take our print and put it in a light booth that has that D50 ISO specified amount of UV radiation. The other thing we can do to solve some of our problems, besides using the right mode on our spectrophotometer, is we can control the storage of our paper where possible. Ideally, we want to keep the paper in a particular temperature, ideally about the temperature of our press room. We want to keep it naturally in a low humidity environment so we don't have problems with substrate dimensionality and with curling. We want to keep the paper out of direct sunlight, which can cause some reactions with some of the papers that we print on, can impact the way they image. And in general, we want to store the paper in the same environment as the press is in, okay? If I have sheets in my warehouse where the humidity is in a certain condition, the temperature is very different than the press room, then when I bring those sheets into the press room, if I put them right in the press, all kinds of strange things are going to happen during the course of that press room as those sheets adjust to a different ambient temperature or humidity. Let's look at how we configure paper settings on our DFE. Generally, on any DFE, and we're going to use the Fiery for an example today, I need to configure the print system for the paper weight and the paper type, by which I mean the coated nature of the paper or the uncoated nature of the paper. I need to establish a calibration for that paper so that in the first place I linearize the tonal response on the paper, and then as I go I can recalibrate back to that state in the future so I get consistent prints over time. I need to make a color profile, sometimes called characterization, which is simply to make an ICC profile for my paper that defines the color gamut and can be used by the color management system on the DFE to convert the colors from what I want them to look like, which might be SWAP or GRACOL or ISO V2, into the range of the press that's defined by this output profile. Okay? The last thing I need to think about with configuring my paper settings, so I set the paper settings for weight and coating. I get a calibration and a profile that work with this paper, and again I'm going to give you a quick demonstration a little bit here of how to do this. I also need to make sure I keep all my other print settings constant. If I chose to take the #1 sheet in your shop and make a calibration and make a profile, and I did all that work on a particular print system at 600 dots per inch with the line 3 screen, and then I come in tomorrow, even if I recalibrate, but I start printing at 1200 dpi with the .1 screen, I'm going to get a very different result. The resolution and halftone screen affect the tonality and really need to be locked in order for the profile and calibration to work the way I intended them to. So specifying paper weight, I'm going to show this again on the Fiery, and paper type are on the Media tab. As we move across through the job properties, we will pick the output profile on the Color tab. And the next tab over you see Image is where we'll set the image quality settings. And again, reminding you that these need to be the same settings we use to make the calibration and profile. So here's the Media section of the job properties, and I can pick on this particular press a normal sheet or a whole bunch of colored sheets here, which aren't very interesting. But if you look down at the bottom of this list, I can also choose a coated glossy or coated matte. Those three settings in particular, normal, meaning natural or uncoated, and coated glossy or coated matte are going to change the parameters of the print system. They're going to change essentially the fuser temperature and perhaps the time at which we use to fuse the toner onto the sheet, and that's going to affect the color gamut. Okay? Before I go on, I can hear what some of you on the webinar today are thinking. You're thinking, I know what I'll do. I'll put the uncoated sheet in my press, but I'll tell him it's glossy coated. And that'll heat up the fuser, so I'll get more color on the uncoated sheet and my customers will like me better. Please don't try this at home. These settings are designed to make your press work in an optimal way, without the paper jamming, without the paper getting stuck, without the paper getting overheated, you having a big service nightmare on your press that takes your manufacturing partner maybe some time to fix for the technician to come out and change parts in the press. So while it is true that this is how the print system works, you really need to set these for the actual paper that you're printing on. If you try to cheat with these settings, you're probably going to cause some harm to your workflows and maybe to your press. The second thing we choose is the paper weight. Again, this is going to vary from DFE to DFE and even from one fiery to another based on which partner's press it's sitting in front of. But in general, we have settings for the different grammages or the different weights of the paper. It's very easy to figure out how to set these settings. If we look at the end of that paper ream that you got or the case of paper, it's going to tell you probably whether it's coated or uncoated, and it's certainly going to tell you the grammage, the GSM, so you can configure this setting properly. Next, we're going to calibrate. Calibration is essential to get consistent results on any paper with any DFE. Generally, if you're going to use a factory calibration set, you're not going to make a new calibration set and profile for your paper. You want to use a paper as much like what the manufacturer used as possible. So on the fiery DFE, we often give you some tips about what that is, or you can reach out to EFI on the forums and find out the particular sheets that we might have used in your press if you want to try to just stick to factory profiles and get a little bit better result. Okay? Really, to get it right, I need to make a custom calibration for your paper. When I do the recalibration later, I need to calibrate on the actual job stock. I know in many shops it's popular and certainly much easier to just calibrate the uncoated sheet in the morning, the 28-pound hammer mill or whatever you might have. That is not going to recalibrate your coated sheet so that it prints consistently later in the day when you're printing uncoated. This leads me to another tip we give around calibration, which is that the best practice is typically to calibrate a substrate right before you use it. I know this isn't always possible, but if you run, let's say, 3 distinct paper types in your workflows, and you come in the morning and calibrate all 3 of them, but you don't use the third paper type until sometime after lunch, you're not going to get as good a result as if you try to put your jobs together. You say, okay, let's calibrate coated. You run as many of the coated jobs as you can. Then you calibrate the uncoated. Maybe you calibrate that third paper at 2 or 3 o'clock in the afternoon before you run the jobs that are going to be on that stock. Talk about profiling. The profile is used in color management to get the best color quality and to match your industry reference. So whether you're trying to match Fogra 39L or GRACOL or some other G7-based standard like SWAP or SWAP 5, that's going to be essential that you have a profile created for your paper. As with calibration, for the best result, we really need to make an actual ICC profile for the paper you're going to print on and for the one you might be using to try to conform with or get compliance with a standard like GRACOL or Fogra. If your paper has optical brightening agents, you're going to need to use M1 measurements. This is a little bit of a gray area here, because if you're not going to look at prints in a light booth, and your customer isn't going to look at prints in a light booth, then you're never going to get it quite right. M1 measurements in general take longer. Certainly on the ES2000 and some other spectrophotometers, we need to scan the patches twice to get an M1 measurement. So if we're in a sort of less controlled environment without a light booth, we might be fine to use M0, which means we scan the patches once, we include all the UV, all the effect of the optical brightening agents, but we understand that if the customer goes in the light booth, where there's lesser quantity of UV, this very exact quantity of UV, then our prints might tend to look yellow. Picking the profile on the fiery is a simple matter of going to the color tab, the basic settings, and we pick our output profile here, as we show. On the fiery, the profile and the calibration are linked together, so I don't have to pick the calibration. When I pick the profile, it automatically selects the calibration that's been linked to when that profile was loaded. To do this to make it easier for you, it can potentially be a challenge if you're trying to make custom profiles using custom calibration sets. Some color management tool sets for making profiles make it a little bit difficult for you to put these together properly and get them linked in the final analysis so they work together correctly. Let's talk a little bit about paper stock and media management. There's really a few simple ways we can automate some of this stuff. So I think by now you've probably already gotten the impression that you don't want different operators in your shop or on different shifts having to pick the paper weight and the paper type and the imaging settings and the profile and the calibration set for every single job they print. So here's some strategies that we have on many DFEs, but particularly on the firing, that can help us to solve these problems. The first one is I can use a server preset. This is a preset that contains all the job settings. I can select it in a single click in the job properties, either from Command Workstation or in the driver workflow if I'm printing from the network. Okay? This works for fireys that are System 10 and later, and we can save it either on our local client, so only we can use it, or we can save it on the firey server so that all the network can see it. This preset contains many, many details, but the ones I'm interested in is that it will specify the paper type, the paper weight, the profile and calibration set that's linked to it, and the imaging settings, such as the halftone screen and the resolution to print at. Creating a preset is a simple matter of saying save preset, putting in a name, and then we just tell it whether we want it to be local on this machine or over on the server for the network to share. A second automated way of configuring my paper handling is to use hot folders. Hot folders in general are a very good way to automate your workflow, especially if you have some other workflow components that maybe want to create PDFs that need to be sent to the firey is a good example. You can just have whatever that workflow is, put the final PDF into the hot folder of the firey, and it goes to the firey directly. Okay? It can be set up to print immediately or to hold, and within the context of the hot folder, we can set the job properties. And you see here in this example, I used that same preset, that server preset I made. I can also pick to use for the hot folder to configure all the paper settings. Before we move on, I should also remind you that in a couple of these workflows, notably hot folders, can have pre-flight turned on so that jobs are automatically pre-flighted with the firey pre-flight tool before they are printed. Naturally, you have to have the pre-flight option on your firey in order for that to be accessible. Third way to automate this is with a virtual printer. Virtual printers are essentially network printers that have a specific set of job properties associated with them. This is really good if you have what we sometimes call a Control-P workflow, which is to say a number of users on your network that print to the firey from their applications by saying Control-P or Command-P on their machine or choosing print from the file menu. They're not typically going to be in Command Workstation to change settings. They're not typically going to be making PDFs or PostScript files they could drop on some hot folder. So the natural way to have them get the right settings for each paper is you put a couple virtual printers on the network. So they know when they have a job for the heavy coded sheet, they print to the virtual printer called heavy coded. When they have a job for uncoded, they print to the virtual printer called, uncoded 24-pound or what have you. We can also automate pre-flight through the virtual printer workflow. This is an example of creating a virtual printer. I basically just go to my job presets, and there's a button here that will publish this as a virtual printer. I can then go into that virtual printer I've created, and if I have the pre-flight option and I want to do that with my jobs, I can specify to pre-flight them in addition to using these exact settings. So as you see here, this is specifying the paper type and the paper weight. And if we dug down a little bit more into this configuration, you'd see the calibration, the profile, and the job properties for imaging. The last way we can do this, and the most sophisticated way to do this on the Fiery is we use our paper catalog. The paper catalog is a centralized media management database. It's the most efficient way to both configure print settings for the paper, and in many cases you can synchronize it with the press, so that when you load the heavy coated paper in the press, you pick the paper catalog entry at the LCD screen where you're loading the paper, and that automatically tells the paper that a particular tray or deck in that machine has the heavy coated. If I look at the Fiery paper catalog and I look down into one of these settings, you'll see that part of the setting is to assign the output profile. Okay, so at the bottom here we see the, if I go back here, we see the front color profile and the back color profile. Paper catalog is also the only way in which I can specify different profiles and calibrations for the front and back of a sheet. Why might I want to do that? Think about a C1S sheet, which is coated one side and uncoated on the other side. This is a way that I could print duplex on that sheet and get proper color management on both sides. One important thing to talk about, and one thing that's enabled by the Fiery, is a mixed media workflow. So this is the notion of having different papers pulled from different trays to print different components of a book, and then using some inline finishing stations that are part of our digital press to create final finished booklets. A couple of notes here. If you're doing mixed media workflows or you want to move to this kind of automated booklet manufacturing workflow, then you are best advised to use the paper catalog, since you'll need different settings for the different papers that are in the press that are going into the book. You should also consider and be aware of engine adjustment time. If I'm printing a brochure that has a heavy coated cover and a plain uncoated, 28-pound guts, that is the contents of the book, I'm going to have a significant time delay between printing the coated and the uncoated sheets, simply because the press characteristics have to change. Mainly, that's the fuser that has to either heat up to print the coated sheet or be let to cool down before we print the uncoated sheet. Okay, so we can assign our profile and calibration using one of these strategies that we've discussed. We really should have a custom calibration and profile for each substrate, in some cases one per side, the example I gave. Before we turn to questions and answers, I want to just give you a quick demonstration of a way to create these calibrations and profiles using Color Profiler Suite. So this is the Color Profiler Suite, which is an option with the Fiery for making ICC profiles using your ES2000 or many other spectrophotometers. The Express Profiler module of Color Profiler Suite simplifies and streamlines this whole process of getting a calibration in a profile. It takes just 5 steps. Basically, it supports any spectrophotometer you'd have in your shop. And what's important is that in addition to making a calibration for your paper and making a profile for your paper, at the end it links them together into a server preset. Now you can choose them using that preset, so you know you get all the right settings for that paper, including the imaging settings. It also makes a paper catalog update. If you've printed from the Express Profiler on a paper catalog entry on the Fiery, we're going to put the paper profile into that paper catalog entry. And finally, of course, you can use this preset to establish some other things. We create a virtual printer for you automatically. You could also create a hot folder workflow and use the preset for that. So here's the 5 quick steps. We launched the Express Profiler. We took our Fiery and give a name. Configure our job properties. Remember, everything that I configure here is going to be stored into the preset that I get at the end. Calibration pages print and are measured. Profiling pages print and are measured. And at the end, after measuring that second set of patches, the software automatically makes a profile, links it to the calibration set that's created in the previous set, puts all that on the Fiery, and again creates a preset in a virtual printer so that it's very easy for you to access. So there's the virtual printer that was created by that workflow, and there is the there's the preset that was created by the Express workflow, and here's the virtual printer that the Express Profiler module created. Finally, we look at the paper catalog entry for the paper that I used with Express. I got that updated as well. Let me do a quick review, and I want to turn it over to Heather for a few minutes to talk to you about some additional resources where you can learn more about digital printing in general, and also especially about paper and color and some of the topics we've covered today. So what we learned today was we learned a little bit about the paper manufacturing process and the characteristics that that process gives to paper. We learned about quality considerations for stock selection and characteristics of paper, including the smoothness, the coating, the brightness, and the color shade. We talked about optical brightening agents, the OBAs, that tend to make cheaper papers look more blue and can sometimes make profiling a bit of a challenge if we don't use the right setting. We talked about some ideas and general strategy for storing paper, keeping paper as much like the press room condition as we can so that we don't have dimensional and other kinds of problems with humidity and temperature. And we showed some settings on the Fiery, that is the paper critical configuration pieces we need to get right to get that particular type of substrate to print properly. And finally, we shared with you several automated ways that we can configure paper and print processing to get the paper settings and the color calibration and profile all tied together so that we get the right result. So let me turn it over to Heather for a moment to talk to you about resources. We're going to move to a Q&A, questions and answers after this. So if you want to start to think about those and submit some questions in the chat window, I'll be ready to come back to you and start to take your questions in just a minute. Heather?
Great. Thank you, Lou. So we put together many great resources available to you, including color-related webinars that are listed here that cover color fundamentals, spot color matching, and the importance of color standards. You can view the recording of these sessions when we provide you with direct links in the thank you email that will be sent to you in a few days with additional links to all of our resources. Be sure to register for other future World of Fiery webinars to help keep you up to date on the latest technologies and trends. Our next one will be on October 7th, and we will cover the variable data printing, and you'll be able to walk away learning how to create powerful VDP campaigns. Next slide, Lou. Lou, can you move to the next slide, please? Thank you. Be sure to check out our Fiery Global University e-learning courses at training.efi.com. This way you can enhance your Fiery product knowledge and productivity. We have also put together a specific e-learning bundle for you comprised of courses that cover how to create automated workflows, color profiling, and digital media workflows. You can get all of these courses for free until the end of October, and we will send you details of how to enroll again in the email. Be sure to download the white paper, Configuring Fiery Color Settings to Optimize Your Print Quality, the how-to guide for paper stock management, as well as the Demystifying Color Standards white paper as great supplements to this webinar. There's also a UV light frequently asked questions document, and this describes when to include or when to cut the UV light when you're creating your color profiles. Read the how-to guide and watch a video to learn how to create custom output profiles with Express Profiler. And as always, you have access to our Fiery online resources with everything you need to know about your Fiery products, and this includes software downloads, training resources, and more. And again, all links will be provided to you in the follow-up email that you will receive in a few days. Now on our next slide, there we go. Here we have some more additional resources, including topics on the latest advice on standards and specifications, including FOGRA, G7, and GRACOL, as well as best practices for publishing and packaging workflows, successful color management with papers with optical brightening agents, and as well as more information on PDFX. So now we can start the Q&A session, and we will answer some of the questions that you have been submitting.
Okay, well, we have a number of questions that have come in here. I want to remind you, you have heard this before if you've attended other World of Fiery webinars, that we typically will run out of time here in about 8 minutes. We may go a few minutes over if you're able to stay, but I want to remind you also that no matter what set of the questions I'm able to take directly in the webinar today, we will, in the thank you email, send you a complete set of the questions and answers so you can, number one, get a repeat of what I've said on the call here, and number two, if one of your questions, for some reason, if we didn't get to it, you'll see the answer in that thank you email. So the first question I have is a great question, very typical and natural thing you want to know. Maybe I didn't explain this in my presentation. Simply says, how does the color gamut behave comparing a calendared sheet to a coded sheet to an uncoded sheet? Okay? And the main thing is that you got the concept that those different paper types are going to have different color gamuts. The answer is generally that the number one coded sheet is going to have the most gamut. If I have two coded sheets and one of them is heavier, that's going to fuse at a higher temperature, that is significantly heavier. It might even have a little more gamut. From coded, the next gamut I would expect down is the uncoded sheet, and probably a super calendared sheet might have a little bit more gamut than a real matte, rough finish, something that looks like a hand-laid paper, simply because the super calendared sheet is very smooth. While I don't have a clay coating for the toner to stick to, I do have a very smooth surface to fuse the toner onto. So I would expect the super calendared would be kind of in the middle, uncoded the lowest gamut, and coded would have the biggest color gamut. The next question I have is, in the paper settings, I'm running a clay-coated paper that doesn't really come across as a coated paper. What setting should I use? Well, you may have a very smooth sheet that seems to have a coating on it but is actually uncoated. My suggestion would be that you run that as a coated paper. Remember, the fiery DFE and your digital press are very easily able to handle something if you might say coated paper, but he's only 90 GSM, which is to say this is a very thin, light coated paper, and that's probably a fine way to print on that sheet. The next question, another very good question, what's the difference between calibration and profiling? Calibration is measuring the individual toner channels. So when I print the calibration page, I basically have a row of patches that I measure that are nothing but cyan. And I have a second row that's nothing but magenta, another row that's nothing but yellow, and another row that's only the black. What the calibration does when I measure those patches is it first determines the maximum density for each of those four colors if I'm making a new calibration set, because the maximum densities are going to be different on my paper than on the factory paper, right? They're going to be higher on a coated sheet and lower on an uncoated sheet. And then the second thing calibration does is it creates a linear tonal response between that Vmax and the lightest printed patch, which is simply to say if you think of those printed patches as having different dot percentages in them, so obviously there's the solid at one end that I measured and there's a very light patch at the other end, maybe it's 3% or 5% dot area coverage. The steps in between probably represent something like 10%, 15%, 20%, 50%, etc., up to 100% dot area coverage. When I calibrate the fiery, I make it so those steps are even, so that the change in tonality from each dot percentage patch to the next one is relatively equal and is kind of aligned with human perception. So all calibration does is get me smooth tonal response, and it records my maximum delta E so I can recalibrate later. Profiling uses overprints. When we make a profile, the patches include both pure cyan, magenta, yellow, and black patches in all different tints, but they also include overprints, combinations of different tints of cyan, magenta, yellow, and black that I can measure to make an ICC profile. So if we think about how these are used in the fiery, or any DFE, a calibration basically just tells me what to do with the individual color channels, how to straighten out the linearity of the cyan, magenta, yellow, and black. The profile is used in a much more complicated color transformation that is a multi-dimensional color transformation. It doesn't just make the cyan, magenta, yellow, and black darker or lighter. It actually changes the way all those colors mix to make overprints like reds and greens and blues and all the colors of the rainbow. So they're very different things. Calibration is essential to setting up a paper if you're going to make a custom profile. If you're not making custom profiles with a tool like Color Profiler Suite, then you're just basically going to be recalibrating the factory profiles and the factory calibration sets, which is perfectly fine. You're going to be getting them to be linear again the way they were at the factory when we made the profile, meaning you're going to make the factory profile work as well as it possibly can. Another question here is, should I calibrate before a big job? Well, I certainly would. Different workflows have different requirements and different, amounts of time to do different things depending on how you start up the shop and how many shifts you run. But yes, if you're going to run a big job or an important job and you, let's say, haven't calibrated for at least half of a shift, I would typically calibrate right before you run that. Next one. Does any available light booth lamps actually conform to ISO 13655 specification? I thought not. Well, there's a couple of ISOs here. Let me try to sort it out a little bit for you. The ISO spec for the lamp light booth is 3664-2009. Manufacturers like GTI and just Normalect do manufacture lamps that very closely comply with 3664-2009. I think if you go on either of those companies' websites, they have a little guide somewhere that tells you what the ends of the lamps should look like. That is, what's the label on their lamps to make sure it's a 2009 compliant lamp. Once you have those lamps are by definition M1. 13655 talks about the difference between measuring M0, measuring M1, measuring M2, and it also includes another one called M3, which is a polarized measurement that not too many devices are supporting today. If you use light booths or light booth bulbs from these manufacturers that comply with ISO 3664-2009, and M1 measurements will precisely match the amount of UV in that light. I know it's confusing because you're like, well, how do I measure? Is that in the 3664 spec? No, the measurement's in the 13655 spec because, we can't make this stuff too easy. Everybody would get in the printing business, right? Looking down here, I'm going to take just a couple more questions because I realize we're coming to time. And so I think the last question we can fit here, I have a whole bunch of questions, so we'll send these out to you. And the question is, should I use sRGB or Adobe RGB? And they ask a specific question about which profile gives the best results printing on a particular press with a firing. This is a Xerox C75 color press. The workflow is Photoshop, creating a PDF, using the Fiery to print. If you're creating content in Photoshop, then the gamut of Adobe RGB is going to much more realistically capture what you might be bringing in. So it depends a little bit on the source images. If you're making things from scratch, let's say in Photoshop, which you're probably not, Adobe will give you a bigger gamut. If you're bringing images into Photoshop and making these PDFs, then you really need to look at the source of those images. If they're coming from, low-cost consumer cameras say that cost less than $500 US, those are probably already in sRGB space. If you have a professional camera system, a scanning camera back, or some prosumer SLR digital camera that costs maybe $1,000 US or more, there's a very good chance there's a setting on that camera, and some of those cameras are giving you Adobe RGB. So in that case, I would recommend you use Adobe in Photoshop. And the simple answer to your question is whichever setting you're using in the RGB settings for Photoshop should always be matched on the Fiery. So if you decide it's sRGB, set your Fiery to sRGB. You can also do a few simple experiments. One thing you'll see if you mismatch the profiles with flesh tones can sometimes become very red. I'm talking about a Caucasian flesh tone. So try taking one of your Photoshop documents on the screen, go under the Edit menu, to the Assign Profile command in Photoshop, assign Adobe, then assign sRGB. Just ask yourself which one looks better, and that's probably the right answer.
All right, so we are just a couple of minutes over, and as Lou mentioned, we do have quite a number of questions that we didn't get to. So as promised at the beginning, we will get back to each of you with an answer to your question individually. So expect that email hopefully sometime soon in the future. We will also compile an FAQ that will have all the questions and answers, and the entire audience will have access to that. We did have a couple of questions about whether this presentation will be available. We will make this available as well, so you can download it and have that as a resource for you. We'll include a link to that when we send you the follow-up email in a few days. So lots of great resources for you coming. Give us a few days to gather everything up and send you that email. With that, I'd like to thank our audience for joining us, staying a few minutes over. Hopefully you found this very useful and informative. I want to thank our presenters, Lou and Heather, for all the great information they shared today. And we look forward to seeing you in October when we'll talk about VDP. So with that, take care. We'll see you then.